Students, welcome to the session. We were doing integration and we have learned the simple formulas. By using those simple formulas, we can find out the integrals of the various kinds of functions. Now, this is a new variety of questions, right? Evaluate x cube upon 2x plus 1 dx. So, before proceeding the solution of this integral, let me tell you one more thing. Whenever you have given a function of the type of this fx divided by gx and dx, fx is in numerator and gx is denominator, and if degree of numerator is less than degree of denominator, only then this integral exists. Exist means we can find out the integral of such type of functions only if the degree of numerator is less than degree of denominator. This is the basic requirement to find out the integral of any function of the type of this, right? Now look at this function. Here fx is given as x cube, gx is given as 2x plus 1, right? So degree of x cube is 3 and degree of 2x plus 1 is 1. So degree of numerator is greater than degree of denominator. And what is the condition? The condition is the degree of numerator should be less than degree of denominator. But here the condition is reverse. So what we will do? We will reduce the degree of numerator by using any technique, any method. So what are the method or what is the technique which we can use? That is only division. So what we will do here, we will divide x cube by 2x plus 1 as usual as we divide the numbers, and the process of division will remain continue till the degree of the remainder is equals to the degree of the remainder is less than degree of denominator. Okay, let me repeat again. The process of division will remain continue till the degree of the remainder should less than degree of denominator. It means here the degree of the denominator is 1. So the degree of the remainder should come out to be less than 1, that is 0. When the degree of the remainder comes out to be 0, then the process of division should be stopped out, right? So see this, we are dividing x cube by 2x plus 1. So here what we will do here, take the quotient. What should be the quotient? Quotient, it should be x square by 2. So because if x square by 2 is multiplied by 2x plus 1, you will get here x cube, right? So this is our first quotient. X cube by 2 multiplied by 2x, you will get here x cube, right? Plus x square by 2. So change the sign. This is not minus, this is minus here, this is plus, right? And this is minus, change the sign. So this will be cancels out. What is left? Minus 1 upon 2 x square. Now what should be the quotient? This minus is here, so we will take the minus here. The quotient should be such that if this quotient is multiplied with the divisor, the product should be minus 1 upon 2 x square. So the quotient should be minus 1 upon 4x. See, minus 1 upon 4x, if multiplied with 2x, you will get here minus 1 upon 2x square, right? And minus 1 upon 4x as it is. This is minus, change the sign. So this is again cancels out. What is left? 1 upon 4x is left. So here the remainder is 1 upon 4x. Its degree is still 1. And the degree of denominator is also 1. And what we want to do? We want to make the degree of the remainder less than 1, that is 0. So we will again divide. The division process will still remain continue. So 1 upon 4 x is here 2x, so 1 upon 8 will be your quotient. If 1 upon 8 is multiplied with 2x, you will get here, see, 1 upon 4x, right? plus 1 upon 8. Change the sign. This will cancel out. What is left? Minus 1 upon 8. So this is the quotient, this is the remainder, and this is the divisor, right? And you know, from very simple mathematics at your earlier classes, what we did here, if we are dividing say 5 by 2, this can be written as, see, divide 5 by 2 to the 4, 1. So 2 is the quotient, 1 is the remainder, and 2 is the divisor. So this can be written as 2 plus 1 upon 2, right? This is your quotient plus remainder divided by divisor. So we will use the same technique here. X cube upon 2x plus 1 dx can be written as, this is your quotient, right? X square by 2 minus 1 upon 4x plus 1 upon 8. This is your quotient. So this is your quotient as it is, minus remainder upon divisor. Remainder is minus 1 upon 8 and divisor is 2x plus 1. So minus 1 upon 8, 2x plus 1, right? Now you can integrate it. First separate them. This can be written as x square by 2 dx minus 1 upon 4 can be taken outside, 1 upon 4 x dx plus 1 upon 8 dx minus 1 upon 8 2x plus 1 dx. And you know the integral of x square is x cube by 3. The integral of x is x square by 2. The integral of dx is simply x, and the integral of 1 upon 2x plus 1. Yes, see this, integral of 1 upon 2x plus 1 dx. This is equals to log 2x plus 1, and this 2 will come out to be here, right? So this 2 and 8 you will get here 16. So this is the required integral of the given function, right? Now let us take this example. If f dash x is equals to 3x square plus 12 upon x cube and f1 is 4, then find fx. So what is given here? Here derivative of a function is given and you have to find out the original function. Means we will use the technique of integration directly to get the original function from its derivative. Is called integration. See, f dash x is given as 3x square divided by 3x square plus 12 upon x cube, integrating both sides. So when we will integrate f dash x, we will get as its function fx, right? So this is fx. And integral of 3x square minus integral of 12 upon x cube. What will be its integral? Its integral will be 3 into x cube by 3 minus 12 can be taken outside. We write here as x3 dx. This 3 and 3 will be cancels out. So x cube is left here minus 12. This we can take here x minus 3 dx. And you know the formula of x raised to the power n, x power minus 3 plus 1 upon minus 3 plus 1 plus a constant. So what you will get? This is equals to x power minus 2 divided by minus 2 plus c. So how you can write it? Minus 1 upon 2 x square plus c, right? So this is what? 3 into x cube by 3, 3 and 3 will be cancels out, this 2 will be cancelled out. What is left? X cube only here and 6 upon c x square plus c. This is your function fx. So fx is coming out to be x cube minus 6x square plus c. Now what is given here? We have given that f1 is equals to 4. See, if fx is equals to, see this fx is, we are getting x cube minus 6 upon x square plus c, right? What is f1? f1 means put x is equals to 1. So we will get here 1 minus 6 plus c, right? So what is f1? f1 is 6 plus 1 is what? That is 5 minus 5 plus c. And what is f1? f1 is given 4. So 4 is equals to minus 5 plus c. So c is coming out to be 9. So put the value of c in our original function. We will get the function as f of x is equals to x cube minus 6 upon x square plus 9 is the required function. and if this function is correct, you can find out its derivative. You will get 3x square plus 12 upon x cube as its derivative, right? Now, after having the process of integration by using some standard formulas, and then we will move to another approach as we did in case of derivatives. In case of derivatives, we have used a number of methods in a sequence to find out the derivatives of the various kinds of functions. So, likewise, we will also use a number of functions in number of methods in steps to find out the integral of the various functions. So, in that sense, integration by substitution is another way out to find out the integral of some standard functions. So, often it is given that the integral is neither in simple or standard form. So, there are many situations in many times what happens, the functions given to us or to whose integral we want to calculate, they are neither in a simple form nor in a standard form. Nor in a standard form means we cannot use any standard formula to find out its integral. Then we will transform such functions to some standard forms by using a suitable substitution. And this substitution is known as the method of integration by substitution, right? And the simple process is what? If gx is a given function, then evaluate the integral. This is gx, its derivative dx. So what we did? We take gx is equals to t. If this gx becomes t, what is left? G dash x dx. Find out its derivative. G dash x dx is dt. So we have taken this as t, and this becomes dt. So it will transform to t dt, and then we can integrate the given function, right? So this function will reduce to, if gx is t, then g dash x dx is dt. So we will, this will transform t dt, and then we can integrate it, right? The variable x dx has been transformed, substituted by the new variable, that is t dt. Let us take some example, you will understand it very easily. Evaluate the integral this following: 3x plus 4, its power is 3. See, can we find out its integral by using the known formulas which we have discussed? I mean, if we don't have any idea of the method of substitution, then can we find out its integral? Of course, the answer is yes. See, this is our function 3x plus 4, its power is 3 dx. You can assume this whole as x. So, it will be treated as x power 3. We can directly use the formula of x raised to power n to write down its integral, right? Because x is simply replaced by 3x plus 4 here. But we want to use the method of substitution. See, what we will do by substitution? Substitution simply means here the function is given in terms of x and dx. Our variable is x. So what we will do, this function is not, for example, in standard form. We cannot find out its integral easily by using the known methods or known formulas. Then we will use the method of substitution, right? So what we will do, we will change, and we will substitute the variables x dx with a new variable, that is t and dt. This is the method which it simply refers to and known as the method of substitution. So see what we will do. We want to integrate this function 3x plus 4 raised to the power 3. If we take 3x plus 4 is equals to t, we take t is equals to 3x plus 4. So see, what will we change? We have taken 3x plus 4 is equals to t, so it has been transformed to t3. dx, naturally if this is t, then dx should be transformed to dt, and this we can calculate from here. We have taken this t is equals to 3x plus 4, right? So what is the value of dt over dx? Its derivative is 3. What we want to calculate? We want to calculate the value of dx. So from here, dt upon 3, this is equals to dx, right? See, it has been converted to 2 cube, and dx is converted to dt divided by 3. Now this can be written as 1 upon 3 being a constant should be taken outside, and what is this? T3 dt, and we know the integral of T3 is T4 upon 4. And then finally put the value of t. You cannot leave the answer in terms of t because the function is given in terms of x. So the answer should also given in terms of x. So replace the value of t. So 3 into 4, that is 1 upon 12. Put the value of t as 3x plus 4. Its power is 4 plus c. So this is the required integral of the given function. And on the similar patterns, I leave this question as an exercise for you pupil. I have solved it and then try to find out its solution yourself. If not, then you can go through the solution of this example, right? Let us take this. Evaluate the following integral x cube upon 1 plus x square power 3 dx. See, here the power of nr is 3, but the power of dr will be more than 3 because 1 plus x square raised to power 3, when you will expand it, the power of dr will become x raised to power 6. So the condition is satisfied. Our condition is satisfied, that is the degree of nr should be less than degree of dr. Here the degree of nr is less than degree of dr because degree of nr is 3, and when we will expand the denominator, the degree of dr will become 6. So see what we will do here. Here again we will use the method of substitution because we cannot find out the integral of this function by using any one of the known formula which we have already discussed. So naturally, if we don't have any standard formula to find out the derivative of integral of this function, then we will use the way out what we know. We know only the method of substitution. So we will try to find out its solution by using the method of substitution. See here what they did here. Here in nr we have x power 3, but in dr we have 1 plus x square raised to power 3. So we will make nr and dr of the same power. This x cube can be written as x square into x, right? No problem. This x cube divided by 1 plus x square and its power is 3 dx. This is our function. This x cube can be written as x square into x divided by 1 plus x square power 3 dx. We make these changes because the power of x is 2 in denominator. It will be helpful for us. Now after that we will take 1 plus x square as t. See, if 1 plus x square is t, then what will happen? 1 plus x square, we have taken this term as t, so we are getting here t raised to power 3. What is left? What is left? X square into x. So if 1 plus x square is t, then the value of x square from here will be t minus 1, right? So x square is what? T minus 1. What is left? X dx. Now find out the value of x dx. See, if x square is equals to t minus 1, then 2x dx is equals to what? Dt. So x dx will be equals to dt by 2, right? So x dx is dt by 2. So what you will get here? T minus 1 t cube, and the value of x dx is dt by 2. So what is left here? 1 upon 2 can be taken outside. We will get here t minus 1 divided by t cube dt, right? This term. Simple. Now this can be written as 1 upon 2 t minus 1. See, t minus 1 upon t cube. This can be written as t upon t cube minus 1 upon t cube, and this is equals to 1 upon t square minus 1 upon t cube, right? In the same way. Now 1 upon t square minus 1 upon t cube, this is step. Now write them separately. 1 upon 2. This t2 can be transferred from denominator to numerator. So we will get here 1 upon 2 t raised to the power minus 2 dt. Likewise, t3 can be transferred from denominator to numerator. We will get here 1 upon 2 t minus 3, and now we can use the formula of x raised to the power n to find out their integrals, and finally replace the value of t by the variable x to write down the final answer, because the answer must be in terms of x, not in terms of t, right? Now after that, having the method of substitution, this is also another approach to find out some specific integrals. This approach is what we can find out the integration of the type of the function this. See, whenever there are certain functions which are of the type of this f dash x divided by fx and then dx. See, what is this? If you look at this function carefully, the numerator of this function is the direct derivative of denominator, right? So whenever we have any function of the type of this, means numerator is the direct derivative of denominator, then its integral is directly equals to log of denominator, right? Because if we will take, see, if we will take fx is equals to t, we take this fx as t. So what we will get here? 1 upon t. What is left? F dash x dx. Find out its derivative. F dash x dx is dt. So f dash x dx is dt. So you will get here dt. This is t. And you know the integral of 1 upon t is log t plus a constant. And we can change the value of t as log t is fx. So whenever we have a function of the type of this nr is the direct derivative of dr, then such integrals can be directly evaluated by taking denominator is equals to t, and finally its integral will come out to be log of denominator. Let us understand this technique by the following examples. See, find out, evaluate the following. See this one. Here 1 upon x log x, and then within bracket log x, log of log x. So what we will do here, we will use here the method of substitution. See how does it work. This is also the case of substitution. We can use the substitution because we also use the method of substitution here. So here if we take log of log x is equals to t, this means we have taken this portion as t. Look at carefully. So what we will get here, what is left? If this is t, then what is left? Dx upon x log x. See this, t is taken as log of log x base e. This we have taken t, right? So what is the value of dt over dx? Find out its derivative. Derivative of log x is 1 upon x. Here in place of x we are having log x itself. So we will get here log x into derivative of log x is this. So we will get here dt over dx as 1 upon x log x, right? So how it will be transformed? This we have taken as t. And what is left? Dx upon x log x. See carefully what is left. Dx in numerator and here x log x. This is left. See dx upon x log x. See from here dt will be what? Dx upon x log x, right? So the value of dt is dx log x log x. So this will be transformed in dt divided by t. And dt divided by t, its integral is log t plus c. Put the value of t, you will get this as its required integral. Are you getting this technique or not? Actually, this is the case of substitution. We can use the substitution. Let me explain once. Our question is, see, integral of 1 upon x log x. See, to understand it clearly, x log x, and then within bracket we are having log of log x, right? This, and this is tx, or sorry, log of log x, and then bracket log of log x, right? Log of log x. This is our case. So what we did here, we have taken this term as t. So t is equals to, see carefully, log of log x. This we have taken t, right? So what is left? The left portion is dx divided by x log x. See it carefully. This has become t, this portion. What is left? Dx upon x log x. So if this is t, what is left? We will have to find out the value of dx upon x log x. So that we can obtain from here. Dt over dx is what? Log of log x. Derivative of log x is 1 upon x. In place of x, we are having itself log x. So what we will get here? 1 upon log x into derivative of log x is 1. So dt over dx is coming out to be 1 upon x log x. What we want to calculate? See, dx upon x log x. So from here, dt is equals to dx upon x log x, right? See, this is t and dx upon x log x is dt. So the equation will transformed in dt upon t. This one, right? An integral of 1 upon t is, log t, and replace the value of t what we have substituted, because we cannot write down our answer in terms of t. Rather, we should mention our answers in terms of x, because the function is given in terms of x. On a similar pattern, we can do this question also. See, x plus 1, x plus log x raised to the power 2 divided by x. So our first objective is what we should substitute. If we will substitute x is equals to t, we cannot obtain the remaining portion by taking t is equals to x. If we substitute x plus 1 is equals to t, we cannot obtain the remaining portion by taking x plus 1 is equals to t. So what is left? X plus log x. Actually, we substitute that portion is equals to t, from which we can obtain the remaining portion of the given function. This is the best way out. So here, if you take t is equals to x, from x you cannot find out x plus 1 or x plus log x. So it is ruled out. If you take t is equals to x plus 1, then from x plus 1 you cannot find out x plus log x. It is also ruled out. And if you take x is equals to x plus log x, then we have a chances of getting x plus 1 as well as x. So this is how we can select or choose what portion should be taken as t. So see here, if we take x plus log x is equals to t, see, t is equals to x plus log x, right? Then dt over dx is what? What is the value of this? 1 plus 1 upon x, and this can be written as x plus 1 upon x. See, if we have taken this portion as t, look at carefully, so it becomes t square. What is left? X plus 1 upon x dx. So see here, dt is what? X plus 1 upon x and then dx. So the value of x plus 1 upon x dx is dt. So see, we have taken x plus 1, x plus log x as t. So it becomes t square. What is left? X plus 1 dx divided by x, and the value of x plus 1 dx divided by x is simply dt. So what we will get here, this is t square and the left portion is tt. And the integral of t square is what? T cube by 3 plus c. And what is t? T we have taken as x plus log x, its power 3 divided by 3 plus c. It's all about the integration of the given function. So this is how we can use few techniques, and we have discussed in this lecture 2 or 3 types of methods which will helpful to find out the integral of the various kinds of function. So students, I should stop this lecture here, and the subsequent text I will take up in the next lecture. Thank you very much.